Hi guys, welcome to my channel and welcome to my calculus in 5 minutes series where I teach calculus in an easy and interesting way. Today, I'm going to continue from where we stop. In the last video, you were told the meaning of function and variables. I define function as a relation or expression that involves one or many variables. Then I explained y as dependent variable and x as an independent variables. I gave you example on this. Also, I told you that when you have your y is equal to f of x, we know already that this is independent variable. We know that this is dependent variable based on the explanation I gave. I said if your f of x is equal to f of minus x, that is for any number of x, if this is satisfied, then we call this even function. Likewise, for any value of x, if I have my f of x equal to minus f of x, then this is odd function. Today we are going to start with differentiation. What do you understand by differentiation? For example, if I have my y to be function of x again, so derivative, let me say your differentiation, which is also called derivatives. So it is also known as differential coefficient. Differential coefficient, you can call it derivative or derived functions. Or derived functions. So it means basically that is when you have your y is equal to f of x, or let me say y is s raised to power n, then your derivative, which is also called differential coefficient or derived functions, which could also be written as y prime or your dy dx. So your f prime of x, in some textbook, it could be written as y dot. So it is what? Nx n minus 1. That is what you are going to do is to take your index, that is your power here, multiply it by the number you have here. So then subtract 1 from the index to get the new index. For example, if I have my y is equal to s raised to power 3, then you don't need to stress yourself. So basically, I will not go into the rules of differentiation because of the scope of this course. So if y is equal to s raised to power 3, then your dy dx is going to be what? 3x, then you subtract 1 from here. So that's 3 minus 1. That will give you 3 s raised to power 2. So that will give you 3 s raised to power 2. Then if you understand that, let me give you an example to back it up. Example, find the derivatives of number 1, y is equal to 3x squared plus 5x plus 7. Number 2, y is equal to 7s cubed plus 3s squared plus 7s plus 9. Yeah, this is very simple. So derivative, which is the rate of change of y with respect to the change in x. So don't forget what I said, that is if you have your y is equal to s raised to power n, then basically your dy dx is nx n minus 1. Okay, now let us take it one by one. Solution. So for the first question, you have the function, you have a quadratic function. Number 1, I have 3x squared plus 5x plus 7. Then my dy dx, so don't forget what I explained here, that is nx n minus 1. But before I continue solving this, let me make you recall of one property in linear algebra known as linearity property. So linearity property. So for your linearity property, we have scalar multiplication and what? And vector addition. When we say scalar multiplication, that is when you have a scalar A and you have a vector X, so then you can conclude adequately that f of Ax is the same thing as A f of X. That's scalar multiplication. Likewise for vector addition, that is when you have your f of A plus B or f of X plus Y, then the same thing as f of A plus f of B. So where A and B is in a space of real number or any space. So when you have something of this nature, then we say that it satisfies linearity property. So likewise, your derivative, which is dy dx, your dy dx, that is the differential operator, also satisfy this property, which we are going to use. So then I can conclude here that, don't forget, d dx. Remember, my y here is 3x squared plus 5x plus 7. Then you put it here, 3x squared plus 5x plus 7. Then you can apply your linearity property. If you apply your linearity property, then you take this one by one, you apply, don't forget your scalar, your vector addition. So then this will give you d dx 3x squared, d dx of 5x plus d dx of 7. Likewise, you can take out your constant because of the scalar multiplication property. Then I have 7, then d dx of 1. So if we understand this, okay, now let us now differentiate it one by one. D dx of s squared. Remember I said when you have your s raised power n, then your dy dx is what? Nx n minus 1. That is, take this index, multiply it by this x, that will give you nx. Then subtract 1 from this index to get the new index. So if we apply the same thing here, then this will give me 2x raised to power 2 minus 1, then plus 5. Don't you have 1 here before? So then you have what? S raised to power 1 times x is x, 1 minus 1, then plus this one, you can rewrite it as, I think we can write it as s raised to power 0, so that we have an expression in terms of x. S raised to power 0 is 1, right? So okay, now 0 times x is 0. So then any number you multiply by 0 will give you 0 again. Then I'm going to have 6x squared plus 5x. It is as simple as this. Let us take the second example. Then I have 7x cubed. Y is equal to 7x cubed plus 7x squared plus 3x plus 5, right? Then my dy dx is going to be d dx. What is my y? You put it here, 7x cubed plus 7x squared plus 3x plus 5. Excuse me, sir, can I do it directly without writing it one by one? Yes, but it will come to a time so whereby it will be advisable for you to do this to avoid mistake. So then this will give me d dx. Don't forget your linearity property, plus d dx of 7x squared plus d dx of 3x plus d dx of 5. So then this will give me, you can do it together or you take it out. So this will be 21x squared plus 14x, that is 2 times 7. So then 2 minus 1. Then plus, you have 1 here, 1 times 3 will give me 3x. 1 minus 1, 1 minus 1 is 0. Then plus, again, you can rewrite this as s raised to power 0. 0 times 5, this will give you 0. And I'm going to have 21x squared plus 14x plus what? Plus 3. If you check the two examples very well, for the first one, you will observe that when I have a constant like this, you understand now? So when I have a constant like this and a variable directly beside it, you understand now? So that is a linear expression. So whereby you just have a monomial expression like this, that an expression in one terms that is as well a linear. So because your s is raised by one here, you notice that after the derivative, what did I have here? Sorry, this should be 5, not 5x. So you notice that I have 5 here. You understand now? When I have 5x, then I said my derivative is what? Derivative is 5. Likewise, your 7 here is constant. You will notice that after differentiation, then I have 0. Likewise, we check the second example, you will notice that after differentiating these 3s, we had what? So we had 3. So that is d dx of 3x is equal to 3. So likewise, when we differentiated what? When we differentiated 5, which is a constant, so the derivative is equal to what? Is equal to 0. What can you conclude there? You will notice that when you are differentiating something of this nature, ax, that is a monomial expression with what? With a degree of 1, with a variable with degree 1, then your derivative is going to give you what? Your derivative is going to give you the constant beside it. In that sense, when you have 100 or 1000x, derivative of 1000x will give you what? 1000. Likewise, when you have a constant, think of any constant, derivative of constant is 0 like we've shown there. So even if yourself, if you are a constant and we differentiate you, then you are going to get what? You are going to get constant. You can try that out. So that's that, please. Keep this. I'm going to explain more on it in the next video. So likewise, we call something higher derivatives. You know my dy dx, you know that I said when I have my y equals s raised power n, if you are differentiating this, then your dy dx is going to be nx n minus 1. What we've done here is known as what? First order derivative. You can have other derivative as well, such as second order. When we say second order derivative, that is the function you've differentiated before, redifferentiate it. So that is, you know, we have dy dx before, then we should redifferentiate it. You understand now? That is differentiating with respect to what you've differentiated before. You know, if you combine these two together, we are going to have d squared y dx square. So this d squared y dx square is known as second order derivative, which is same thing as y prime prime or f prime prime of s, like I've explained the other time, or y dot dot. You understand now? So you can still have third order derivative, that is what you've differentiated before, that is your second order derivative, which is d squared y dx squared. You should differentiate it. So then I'm going to have what? D cube y dx cube. You understand now, which is also the same thing as y prime prime or f prime 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 of x, just like that. So just like that, then you can have your n order derivative. From there, you can say your nth order derivative is what? That is dny dx raised power n. So let me give you an example to back it up to understand what I'm trying to say. Example, if y is equal to s cube plus 5s plus 9, find y prime, that is the first order derivative, y prime prime and y prime prime prime. You understand? Or let me say at point s is equal to 2. Yeah. Okay, for example number 1, I have y is equal to s cube plus 5s plus 9. Don't forget for y prime means we have to differentiate it once, that is the first order derivative. Then your y prime is going to be, which is same thing as divide s, okay? 3 multiplied by s, that's 3x. Subtract 1 from this index to have new index. Then plus, this will give you 5s. Subtract 1 from it to give you new index, that's 0. Don't forget what I said the other time, derivative of 9 will give me what? Will give me constant. Derivative of constant will give me 0. And 9 here is a constant. Even here, we don't need to stress yourself with what I've explained the other time. Or you have something of this nature, if you have to differentiate this type of expression, just write the constant alone. So then I'm going to have my y prime to be 3x squared plus 5x. That's our first order derivative. But the question says we should find all these derivatives at point s equal to 2. That is, you can now say your dy dx at s equal to 2, meaning where you see x before, you now substitute it with the value of h with the value of 2. And that will give you 3, 2 squared plus 5 into 2. That's 3 multiplied by 4 plus 10, right? So that's 12 plus 10, which is equal to 22. Okay, let us find the second order derivative y prime prime, which is same thing as the squared y dx squared. Don't forget. Remember, the square y dx squared means to differentiate what we've differentiated before. That is differentiating the first order derivative. So that will now give you the dy dx. What did we obtain for our first order derivative? That's 3x squared plus 5x. And if you apply your linearity property, you have 3x squared plus d dy dx of 5x. So, and this will give me nothing but what? So, this will give me 6x plus, don't forget, you don't need to stress yourself. What are you going to have here? So, you are going to have 5. Am I making sense? I think we obtain x raised by 0 here is 1. This is supposed to be 5. So, then if this is 5, if you substitute the value of 2 here, so no, this is not going to be there. Then this will be 12 plus 5, sorry. So which is equal to 17. Yeah. Okay. Then this will be 5, not 5x. Then this is 5. And derivative of constant will give me 0. So it means your d squared y dx squared will be 6x. And don't forget, the question asks us to find if their values at point s equal to 2. So which implies wherever you see x, you substitute the value of 2. So this will give you 12. And lastly, your y prime prime, which is same thing as the cube y dx cube, that is your third order derivative, meaning you are to differentiate your second order derivative, that is the squared y dx square. And don't forget, here we found out that the square y dx squared is 6x, and I'm going to have the dy of 6x. If you differentiate it with what I told you before, derivative of 6x is going to be 6. How? Don't forget, this is x raised by 1. 1 times 6 is 6. If you subtract 1 from this index to get the new one, you are going to have 6 x raised by 0, which is equal to 6. Then you can still find your y, the cube y, the s cube at s equal to 2. You understand that? That is, wherever you see x, you put 2. But you don't have x in this function. In fact, this gives us a constant. Then you are going to write it like that. So this is what we know as higher order derivative. Don't forget, in this video, I said when you have your y equals s raised power n, then in general, your dy dx is equal to ns n minus 1. So then I said you can find higher derivative. So this is the first order, second order, third order. So that is, you are going to differentiate what you've differentiated already. So also I told you, when you have your function in terms of this expression, then your dy dx is going to be a. Likewise, if your function is a constant, if you differentiate it, you are going to have 0. In the next video, I'm going to explain much about this, but before we move, don't forget to subscribe on my channel if not done so before, and don't forget to invite your friend to do the same, like and also share it. Till I see you in the next video.